Okay, so this is sections 2.2. And in this section, we're gonna work with discrete and continuous data to create what is called a histogram. We are also going to work with a dot plot, and we are also going to draw or look at a time series graph. Okay, so anytime, and we kind of already talked about this last section, anytime we have data, be it discrete or continuous, we can graph in categories. Okay. So what we had in the last section was word response data. Okay. It was categorical data, qualitative data. Okay. So everything we did in section 1 was qualitative data. We're now moving on to quantitative data. So we have number data. And number data is graphed slightly differently. So rather than using, and the first example we're going to do is going to keep them all separate. But rather than keeping them all separate, what we can do is we can create categories of the data or classes of data. And what we do is we can lump values together. So if the data is discrete, we can keep them, and there's a small amount of data, a small amount of them, we can keep them as their individual values. If, however, the data is continuous or has a lot of range to it, we're not going to want to draw a bar for every single value. So what we do instead is we create these groups or these classes of data. So I'm going to show you both of them. The first one is going to be a small set of discrete data and how we graph number data different than we graph word data. Okay, so we are still going to create a frequency and relative frequency graph. However, this is going to be with what is called a histogram. It is going to be numerical data, so we use a histogram versus a bar graph. All right, so I'm going to go ahead to the definition here and then go back, and we'll open the data set. So a histogram is constructed by drawing rectangles for each class of data, and the height of each rectangle is the frequency or relative frequency. The width of each rectangle is the same, and the rectangles touch each other. Okay, so bar. In a bar graph, we have categories, and they are separated. A histogram is numbers. 1, 2, 3, 4, 5. And what's going to happen is the bars, as they're drawn, are going to touch each other because we are graphing on a numeric scale. Okay, a histogram will let us graph individually like this, or we can graph groups of data together. Maybe it's we graph every 10 values together. Okay, so a histogram is going to look different because it's number data and we're graphing on a numeric scale versus a bar graph, which is just categories down here. Okay. So let's go back and we're going to open this data set here. So if I click, it is going to open, should open for me in StatCrunch. And it is going to put it all right here for me. Okay, so this data is the number of televisions in, what does it say? In households. Okay, so they sampled, let's see how many, 40 households, and wrote down the number of televisions there are. All right, so we can see here we have the values from what, 0 to 5. So a relatively small data set, discrete values, and what we're going to do is we're going to graph them individually. So we'll graph the 0s, the 1s, the 2s, the 3s, the 4s, and the 5s. Okay, it's going to be individual pieces like that. And then eventually we're going to go to one where we're going to lump some data together. All right, so this is no longer a bar plot. This is a histogram. We are going to graph a histogram of this data set and click compute. And of course, this one's not going to quite draw them together because what they're doing, I think, is drawing from, yeah, they're drawing to the half value since they're whole values. So zeros, there's one of them. 1 happens 14 times. 2 happens 14 times. 3 happens 8 times. 4 happens 2 times. And 5 happens 1 time. So default, when you just use the default, it may not link all of them together. So what I can do is I can go back here and make it a full width of 1. And then the boxes are going to touch each other. 0 has 1, 1 has 14, 2 has 12, 3 has 8, 4 has 2, 5 happens once. Okay, it is very easy again to change it to a relative frequency by just going back to the edit button and change it to a relative frequency. Again, the graph is not going to look much different except for the fact that these values are now on percents. So 35% have 1 television, 35% have 2 televisions, 20% have 3 televisions in their house. All right, so what happens if, again, here's your graphs. If we have a bigger spread of data, what we're going to do is we're going to create what are called classes, and classes are categories into which data are grouped. When a data set consists of large number of different discrete values, or when it is continuous, we must create classes by using intervals of numbers. So we're going to go through a few different examples here. We'll go through kind of how we can do this by hand, and then of course how we just do this in StatCrunch. Okay, so something like this. The data represents the number of mothers in the United States ages 15 to 54 who had their 4th child in 2016. Okay, so it would not make sense to take every single individual age and make a bar for it. Well, you know, I don't need a bar for 20, 21, 22, 23, 24, all the way up. That would be a ton of bars. Okay, let's see, 54 minus 15. How many bars would that be? 54 minus 15, 39 bars. Okay, that would be crazy amount of bars. It would be super cluttered of a graph. So instead what they do is they're grouping them in groups of 5. So 15, 16, 17, 18, 19, that's a group of 5. 20, 21, 22, 23, 24, the next group of 5. So they're lumping 5 age groups together and it's graphing them together instead of individually. Okay, so rather than having, like I said, what was it, 34 or something, 39 individual bars up like this all over the place, what they've done is they lumped into 1, 2, 3, 4, 5, 6, 7, 8 groups. So you've got, you know, I'm totally just estimating, like not drawing to scale anything. But I would group them together rather than having a bunch of individual graphs. So that's what's nice about a histogram here, is that we can kind of group some values together. There is no one set way to do that. This one specifically, we'll talk about here how they did it. So we have what's called the lower class limit, which is the smallest value in a grouping, and the upper class limit, which is the highest value in that grouping. So in this grouping, 15, 19, that's the lower and the upper. And then the next one is 20 to 24, lower to upper. 25 to 29, lower to upper. So each grouping or each class has a lower and upper limit, so we know where the data falls. So here, the lower class is 15. The lower class for the next one is 20. Upper class limit of the first one is 19. We just did that, 15 to 19, 20 to 24. And then you can also talk about what the width is. Well, there's 5 in there, 15, 16, 17, 18, and 19. That is a width of 5 because I have 5 different age groups within one category. Could I have grouped them by 3s? Sure. Could I have grouped them by 6? Sure. But a lot of times it's really easy to work with 15, 20, 25, 30, 35, 40. Those are nice round values that we like to work with. So a lot of times you could use a different grouping, but it makes more sense to instead work with nice values. So let's look at another one here. So the following data represents the total fine, including late penalties in dollars, for a simple random sample of 50 parking and camera violations in the city of New York. Construct a frequency and relative frequency distribution of the data. Okay, so first off, I look at this and I see number data. I see decimals involved, and I see a large range of values. So that is a dead giveaway to say, okay, I need a histogram. So here's how a process would work if you're going to work through it and not just go straight to technology. You would have to find the smallest value. The smallest value is 65, and the largest value is $322.61. So here, smallest, you'd have to search for the smallest value and the highest value. Okay, then you have to decide how you're going to chunk the data. I do not have to start at 65, and I don't have to end exactly at 322.61. Okay, so what this person decided to do is we're going to create classes so that the lower class limit starts at 50, and then we count by 25s. So 50, 75, 100, 125. You want to make it nice and easy to go to. Okay, so because our data is going to go up by 25s, and because our data goes to 2 decimal points, the first, oops, I went the wrong way here. First group is going to go $50 to $74.99. And the next group is going to start at 75 and go up to $99.99, 100 to $124.99. All the way until you go to the highest one is above your highest value. And then we're going to do just like we created our tally table before. I'm going to go through and count and put where they all belong. So 211.09. So 211.09, that's going to go there. 209.29, I'm going the wrong way. 209.29, that goes there. It keeps jumping too far. 150.56. So on and so forth, okay? A lot of data if you were going to do this by hand. Eventually, again, if you're doing this by hand, we would get all of our totals here. This group has 1, this group has none, 7, 10, 5, so on and so forth. And if we wanted, we could turn them all into relative frequency values by dividing each of the frequencies by 50, because I have a total of 50 data values. So 2%, none, 14%, 20%, 10%, so on and so forth. So things to note. The choices of the lower class limit for the first class and class width are arbitrary. It does not matter what you pick, okay? You could have grouped by 10s. You could have grouped by 30s. It doesn't matter. There is no one set way you have to do it, okay? There is no one correct frequency distribution. It is what you as the statistician decide to make, okay? However, some frequency distributions can better illustrate patterns within the data than others. So you may have to tweak it a little bit. Maybe you have too few bars and you need to add a few more. It's a little bit of give and take. You want to make sure you have enough bars, but you don't want to have too many, okay? But you also don't want to have too little, because then it's not going to show really how your data is working. Okay, so use what you think looks the best, has a decent amount of bars. All right, so some guidelines to do it. We kind of walked through this already. Choose the smallest observation and pick something that's slightly lower. That is a nice round convenient number. And then decide on how many groups you want. Okay, if you want 10 bars, figure out how far your lowest and highest are, and divide by how many groups you want is going to roughly give you your class width. Or like I said, you just make it nice round values. Go 5s, 10s, 20s, 25s. There is no set way to do it. Okay, and I will show you guys, as I said here, how to do all of this within StatCrunch here in just a second. All right, so let's look at this graph specifically. 50 to 74.99 is in this group here, then 75 to 99.99. Remember, we had 0, and you can see how each one is grouped together. So when you're looking at a histogram here, this one on the left is included in here. So 75 is in this one, 100 is in this one, 125 is the start of this one. So this is 50 to 74.99. Because 75 is in the next one. Okay. So the value on the here is always to the start of the next histogram box. And again, I can change between a frequency and relative frequency. It's not going to change the overall look of the graph. It's just going to change the values that are on the side. Do I want total values or do I want percentage values? Again, depending on what I'm trying to show, depending on what I'm talking about here is going to determine regular or relative. Okay, so how do you do this? I give you data and it says, hey, create a histogram. Gives you no standards at all. Just wants you to create it. All right, so let's open our data set here. So let's take a look. I have 51 pieces of information, 51 income values. So if I wanted, I could just go to graph a histogram, select my value, and click compute, and just let StatCrunch do it all for me. Okay, I have that option. And what it's going to do here is it's going to show you here, this is 40,000, but 45,000 is the start of the next one. So 40,000, what would that be? 44,999. And then this next one starts at 45,000. This one starts at 50,000, 55,000, 60,000, 65,000, 70,000. Okay, so they started at 40,000 and graphed every 5,000. So, well, let's say I didn't want to do that. Let me say I want to instead start at 40,000 and I want to graph every 8,000. Now, clearly this isn't going to be as nice of values, but it has a few less bars. So you have the option to tweak it for what you want. So I have a few less bars, but these values down here maybe aren't as nice to work with as the nice round 5s. Okay. Showing you here that making it less bars, let's do 2,000, makes it a lot more confusing to look at. Okay. I don't want to have too many bars and I don't want to have too little bars. So that's kind of why if you leave it up to StatCrunch to just do it itself, it kind of does that for you. It creates kind of a good middle ground graph. If it specifically says, start it at, there you go, there's your start at, and if it tells you your width, you can enter those values in, okay? If it doesn't tell you, just get rid of them. They're optional. You don't have to do it, and you can let StatCrunch create it itself. But if it does tell you, hey, start the graph at this, graph it to here, that's a good way. That's right where you do it. All right, so let me really quick here see if there's an extra one in the homework we want to try. All right, so here's an example from the homework. Create a graphical summary. Let's see here. Internet media and market research firm measured the amount of time an individual spends viewing a specific web page. The data in the accompanying table represents the amount of time in seconds a random sample of 40 surfers spent viewing the web page. Create a graphical summary and write a sentence that describes the data. So it looks like here, each one, what is that? 20, 40, 60, 80. It looks like they're grouping it by every 20. All right, so if I open my table here and I open it in StatCrunch, I'm going to see what it creates first. I don't know if it's going to be exact or not. That's kind of why I was counting, looking at what it did. It looks like it starts at 0 and goes by every 20. So if I default select it, I'm not sure if it's going to go, it's not going by 20. So here's how I know it's not going to look quite the same. I want to make sure that I have it the same. So it started at 0 and graphed every 20. And then from there, this should match exactly one of the graphs that's over here. And I think it looks like that one to me. And then we're going to talk about this part in a little bit. You can't answer that question yet, but yeah, so hopefully that makes sense there. Another graph. So now we're at histograms. Okay. The next graph we're going to talk about is what is called a dot plot. A dot plot is drawn by placing each observation horizontally in increasing order and placing a dot above the observation each time it is observed. Okay, so this is going to look like it's going to look kind of like a bar graph. It's going to look kind of like a histogram, except for it's going to have dots above it. So we're going to draw a dot plot for the number of television data that we had. So what I'm going to do is go back to my StatCrunch here and find my TV data. All right, create a dot plot. So graph, dot plot, I'm going to show you what it looks like. Just going to click it. I do not like the points to overlap. That's just a personal preference. I'm going to turn that off so that I can see them. I'm going to also make this a little bit bigger here. All right, so again, kind of looks like a bar graph, kind of looks like that histogram. But each value, you have to make sure it's scaled. So if you're counting by 1 every time, you have to have it there. If a value doesn't have any data, you still have to put it here. It just has no dots above it. Okay, so 0 has 1, 1 has, I think it was up to 14 if I count correctly. Let me see if I can find that histogram. Oops, nope, don't want to save, Show you how they look next to each other. So 1 for 1, 14, 14. This should have 1, 2, 3, 4, 5, 6, 7, 8 of them. Yep, 8. 2 dots, 1 dot. Okay, would be the same as if I created a bar graph. We have data this time. I have all the raw data. Kind of looks like a bar graph. 1, 14, 14, 8, 2, 1. All right, so I'm just going to show you really quick what would happen. I'm going to delete these 4s out here just to show you if there were no 4s. Okay, you still have the 4 marked on your number line, but there are no data values there. Okay, so if you were to create a dot plot and you don't have a specific value and it's in your scale, you still have to put it there. Just know that there's no dots going to be above it. All right, so let me add those values back in so my data set stays correct and accurate. All right, so that is a dot plot. Like I said, pretty straightforward. It may not be one you're as familiar with, But again, it's just kind of another version of a bar graph, just drawn a little bit differently. Okay, so the next part we're going to talk about here is the shape of these distributions. So this we can discuss when we're really looking with histograms. Okay, we can talk about the shape. So we have 4 different shapes that can happen: uniform, bell, skewed right, and skewed left. So I'm going to describe them here, and then I'll show you an image of them on the next slide. So uniform distribution is the frequency in each value of the variable is evenly spread out across the values of the variable. Okay, now it doesn't have to be exactly perfect to be uniform. There might be slight variation, but it's going to look mostly like all of the values happen about the same frequency. Okay, bell shape. The highest frequency occurs in the middle, and the frequencies tail off to the left and right. A skewed right to tail to the right of the peak is longer than the tail to the left. Skewed left, the tail to the left is longer than the right. All right, so here's what we're going to see. Now, this first one is exactly uniform. Please note that this is not normally realistic. If you're going to get a uniform data set, you're going to have some slight variation. This may be a little higher, a little lower, a little higher. Okay. The goal is, though, if most of the values fall relatively close to that middle line here, they're all about the same height, we can still call it uniform. Okay. Doesn't have to be perfect. There can be slight variation, and it could still be called uniform. Okay, a bell shape. This is that bell-shaped normal curve. Highest in the middle, trails down on the 2 ends. These next 2 are called skewed graphs. If you were to draw the curve above it, the right is longer. It has a right tail that is longer, so it is skewed right. In this one, if I follow up here, the left is longer, so it is skewed left. So uniform, about the same height all the way across. Bell shape is symmetric, higher in the middle, lower on the ends. Right skewed has a right tail that's longer. Left skewed has a left tail that's longer. And if I still have that homework question, we can now answer what is this? Okay, well, it's high here, and then it just goes down to the right. So I'm going to say this is a skewed right graph. Okay, I find my highest value, and then I look at the 2 sides. There is no left side here. It is all to the right. So I'm going to say mine is skewed right. Okay, so you can talk about those here. You can talk about the spread. You can talk about the shape of this one as well. Lots of different things you can talk about. Shapes for the different graphs. I think you're probably going to do that with this one too, because it gives you data set. You may do that with this one. You've got all of them here. Skewed left, bell shape, uniform, skewed right. You've got all of them. Okay, so identify the shape of the following histogram, which represents the fine paid for parking and camera violations in New York City. This one really does. This one's really tricky. The one that I'm going to give you, you're going to be able to tell what the shape is. This, it kind of goes up and down and up and down. There really is no basic shape like the one that we had here. So it says it's fairly symmetric, but not really bell-shaped, because look, you go up, down, up, down. So that's symmetric. We have the same thing happening on this side as this side, but it's not really one of these 4 that we have here. We've got our TV data though. Let's look at our TV data. All right, so it looks like here's my highs, and then if this is my high, I've got 1 to the left and 1, 2, 3 to the right. So there's more to the right. I'm going to call this right skewed. I could go back and find the other data set quick. The income data. There's my high. It's not really bell shaped though. 1, 2, 3, 1, 2. Yeah, this one's a little funky too. I would say it's close to a bell shape. If this one was a little lower, it would definitely be more bell shaped. 1, 2, 3. But I could also see where you could say maybe the right side is a little more skewed. So some of them get a little tricky. The ones I will give you should be pretty easy to spot as to which of the ones they are. I'm not going to give you something that's hard to understand or take a look at. So I'm going to skip this. It's an in-class activity. We are not in class, so I can't have you guys tell me what your resting pulse rate is to be able to do this. We could use random number generators, but hopefully you guys have enough of an understanding of what's going on here. What we could have done, so basically one way to do this is I could have had everybody in class sit and count your pulse, and we would then graph the values. Okay, the other way we could do that is we could randomly generate some values and then graph the values. So we could then discuss what do we think the shape's going to follow, things like that, your heart rate. All of those tend to follow the normal curve. So the normal curve happens because many things in nature just actually measure that way. Anything that's measured as far as height, weight. So anytime, I don't know if any of you have children, but when your children go to the doctor, they tell you like, hey, your child is in the 25% value for height, or your child is in the 50% value for weight. Okay, it's telling you where your kid falls based on other people. And a lot of times you have a lot of people that are gonna be right in the middle, and then further spread out, those values are less common. Okay, we have our average height, and then you've got people that are really tall, really short, and they're gonna follow that normal curve type shape. Okay, so height, weight, your IQ, your blood pressure, your heart rate, any of those things that we can measure in terms of nature are gonna follow that normal distribution. All right, so the last little graph here is going to kind of lead us more really towards what we're going to do in chapter 4 is what's called a time series graph. Also kind of thought of as like a scatter plot. We're going to call it a time series plot here because it's going to graph something with respect to time specifically. So maybe you're tracking the debt every year for the US that we've accrued, or you're tracking your yearly sales for your company. That's going to be a time series plot because I'm plotting something with respect to time. And then what you're going to do is you're going to draw little segments to connect the points. Okay, so example here, the data to the right shows the partisan conflict index or the degree of political disagreement among US politicians. So I'm assuming the higher number, the more disagreement there is versus the lower number. We can chart each year has a PCI value, and what I can do is I can type all those into StatCrunch if I want to, and then I can create my plot. I'm going to show you what it is graphed here for you. So each value has the year, so the time, this is why it's called the time series plot, time, and then the value that it's going to go to up here. So each dot corresponds to a specific data value here of a specific year. And then you can see the overall trends. When did it go up? When did it go down? When was it the highest? When was it the lowest? Okay, and maybe you can go back to something that happened in that year and figure out, okay, this is why it was high, or this is why it was lower. I'm gonna show you guys how to open the data set. So let's go to StatCrunch. View data sets from your textbook. We're in chapter 2. We're in section 2. So I'm gonna try to pick one of these ones on the end here and hope this works. Ooh, I got a good one. Okay, 240. So this is year and life expectancy. So we can do a time series plot for years and life expectancy because it gives me a value for every year. Perfect. So the way we do this one here, we have to do what's called scatter plot. Okay, years is the time, life expectancy is the variable. I'm curious if this will let me put the line as well. It does. Awesome. Okay, so what I did here to get the line, right now it's just on points. So points is just going to graph the points. If I want it to be a time series, though, I need to have the line drawn as well. So I'm going to hit Shift and also select lines. And then if I make this a little bit bigger here, you guys can see that it's connected. And you can see how it changes. Now, we are going to learn in the next section that this graph is a very bad graph. Okay, so we're going to learn that this is a misleading graph. This software did not do a very good job of creating that graph, and you're going to learn why in the next section. So maybe you can come back and look back at this graph and see if you can tell me why it is actually not an accurate or why it's a misleading graph. But we can still see here that this is our time series plot. Each value is going to be there. I'm wondering if I can make it so that it doesn't do that. I don't know that I can. I'll play around with it if I find a way to make it not misleading here. I will do that for you. But you do have the option to add like a title if you wanted to say, how life expectancy has changed. And then it's going to give you your titles. You can always like make your graphs a little more interactive here, explanatory. So yeah, hopefully that helps. Hopefully you are comfortable with most of these graphs. If you forget how to create a graph, you can always go back to the main StatCrunch page here and go to help and more help. And right here, graphs. Okay, I forgot, how do I make a box plot? Well, you can watch it right here. How do I make a histogram? Right here. Pie charts from raw data or summary. Bar plots with raw data or summary. Split or stacked bar plots. All of them are here, and there's graphs to help you do that. So there's always extra little things within this and within Pearson over here to watch extra little helpful things, videos to review if you forget how to create a graph. All right. Well, that's the end of section 2.2, and I will see you in section 2.3.